Assalamualaikum and greetings to all. Welcome back. Okay, let's proceed to example 1.2. We are still on domain and range for multivariable functions. In example 1.2, we are asked to find, sketch. We need to sketch the natural domain of the function. Okay, so in order for us to be able to sketch the domain of the function, we need to find the domain of the function first. Okay, so as you recall from before, domain of a function is set of points at which the function is defined. So okay, let's proceed. Example 2. We're given a function, I'm going to call it z fxy is equal to ln of x squared minus y. Okay, all right, so from engineering math 1, you know that there is restriction for ln. You can only find ln of a positive value, right? So in this case, we have x squared minus y in our function ln. So we know that x squared minus y must be larger than 0. If x squared minus y is less than 0, then we cannot find the ln of the value. Okay, so from here, once we know that x squared minus y must be larger than 0, we can do some mathematical manipulation by taking away y from both sides. So we have this. To make it more professional, instead of writing it this way, we can write it as y less than x squared. Okay, now we can write down the domain. So again, domain would be set of points. So if it's a set, you have to write it between two curly brackets. So set of points xy. Okay, so the restriction for the point xy is y must be larger than x squared. So that's our domain. Okay, now we need to sketch the domain. So sketching the domain, you just need to sketch an area where y is less than x squared. Okay, to do that, we need the xy plane. Okay, so let's say here we have y-axis, and here we have the x-axis. Okay, so let's say this is x and y. Okay, to sketch y less than x squared, we have to sketch y equals x squared first. Okay, y equals x squared, we know it's a parabola open upwards. Okay, so let's sketch that. I'm going to use pink, right? So we have this. This is y equals x squared. But in our domain equal sign here, we need y less than x squared, not equal x squared. So all the points on the curve here is not included in the domain. So instead of using solid curve, we need to use dotted curve. So I'm gonna erase this, right, and plot it again. So instead of using solid curve, I'm going to use the dotted curve, because all the points on this curve are not included as the domain of the function. Okay. Oh well. Okay, so now we have two areas. One is above the curve, and the other is below the curve. So we need to figure out which area represent y less than x squared. Okay. All right. So what you need to do is you need to pick a point in one of the regions. So let's say you pick this point, and that point is roughly, let's say this is x0, y is 4. Okay, let's say. All right, so when x is 0, at that point x is 0, y is 4. Okay, what we want is y less than x squared. So if y is 4 and x is 0, square that, you get 0. Definitely this is 4 is larger than 0, which means that this point 0, 4 is not in the region y less than x squared. Okay, which means your region, the region of the domain, would consist of all the points below the curve y equals x squared. Okay, so this is the sketch of the domain of the function. So this is the domain, and this is the sketch of the domain. All right. Okay. Next example is example 3. Find the domain and the range of the function for 1 over x squared. Okay. Example 3. Example 3, the function is, I'm going to call it z equals fxy, and here we have 1 over x squared. Okay. For the domain, as you can see, this function is a rational function. We have numerator divided by denominator. So this is a rational function. So do remember, for rational function, the denominator cannot be 0. Denominator cannot be 0. Okay, so in our case, the denominator is xy. So xy cannot be 0. So that would be our domain. So remember, domain would be set of points xy, is in this case it's xy, such that the product of x and y cannot be 0. Okay, all right, now let's say we want to sketch this. Oops. Okay, here we go. So let's say you want to sketch this region where x multiplied with y is not 0. Okay, so this is the domain. X can be any real number. X is a real number, y is a real number, but the product of x and y cannot be 0. Okay, let's say we want to sketch this. Okay, so here we have the y-axis and the x-axis. All right, let me ask you, where is x times y is 0? Okay, there are many possibilities. Okay, if x times y is 0, the first case is x is 0. The second case is y is 0. Or the third case is both of them are 0. X is 0 and y is also 0. Okay, so x equals 0 would be everything on the y-axis. This is x0. And for y0 would be everything on the x-axis. So this is y equals 0. I forgot to put the x-axis. This is x-axis and this is y-axis. And then for x0 and y0 would be the origin. Okay, which means that, so if you want to sketch our domain, it would be any other points except the points on the x-axis and the y-axis. So to sketch this, we can use the dotted line. Okay, so the domain, sketch of the domain would be, it doesn't include the y-axis, it doesn't include the x-axis, okay, and the rest of them would be the domain. Okay, so the reason I'm using the dotted curve is because all the points on the curve are not in the domain. So in this case, all the points on the y-axis are not in the domain, all the points on the x-axis are not in the domain, and obviously the origin is not in the domain as well. So all other points are in the domain. So the answer, this is the domain and this is the sketch of the domain. All right, now let's find the range. Okay, so for the range, the function is this, z equals 1 over xy. Okay, for the range we look for all possible values of z. Okay, we have 1 over xy, so x can be positive, can be negative, as long as it's not 0. Y can be positive, can be negative, but it cannot be 0. And of course both x and y cannot be 0 at the same time, otherwise the function is not defined. Okay, so in this case we have 1 over xy. So ask yourself, can z be positive? Yes, it can, when both x and y are 0, or when both x and y are negative. Oh, sorry, let me rewind that. Delete that. Okay. Can z be positive? Yes, it can. It can be positive when both x and y are positive, or when x and y are both negative. So it can be positive. All right. Can z be negative? Yes, it can. It can be negative when either x or y is negative. Okay. Can it be 0? Nope, it cannot be 0, because in order for z to be 0 is for the numerator to be 0. But in this case, our numerator is 1. Okay, so the range would be, it can be positive or negative, but 0. So it cannot be 0. So that's the range of the function 1 over xy. How are we doing with time? 10 minutes. Okay, so I'll continue with more examples in the next video. Thank you.